Hello guys, now in this video I'm going to talk about the gravity experiment that is shown in the BBC documentary hosted by Brian Cox. So in this experiment there are two objects, a bowling ball and a feather, and they are dropped from the same height, and when there is no air in the chamber they hit the ground at the same time. But when there is air, bowling ball hits the ground much earlier than the feather. So Brian Cox gives drag force as an explanation for the bowling ball to hit the ground much earlier than the feather. Yes, indeed, that is the case. Drag force determines the terminal velocity, which is the maximum velocity an object can reach in a medium. And so the terminal velocity of the bowling ball is much higher than the feather, therefore it reaches the ground earlier than the feather. But there is another factor that affects the time it takes for these objects to reach the ground, and that is the buoyancy force. Most of you must be familiar with the Archimedes's buoyancy force. So for example, you place a piece of wood on the surface of the water, it floats, right? That is simply because of the fact that the density of the wood is much lower than the density of the water. So the same principle, buoyancy force, applies not only to liquids but also to gases. For example, hot air balloons, right? The temperature of the air inside the balloon is much higher. Because of that reason, the density of the air inside the balloon is lower compared to the density of the air outside. Because of that, balloon flies, and the reason is the buoyancy force. And this same buoyancy force applies to the gravity experiment, because the density of the feather is very close to the density of the air. It is slightly higher than the density of the air. Because of that reason, there is significant buoyancy force, upwards force. Therefore, it affects the time it reaches the ground. So now I'm going to show you a simulation that I made. I wrote a Python code for different cases. In case when there is no air in the chamber, and when only the drag force is acting on the objects, and in the third case when there is only the buoyancy force is acting on the object. So you see them on the left up corner of the video, the simulation. As you can see, when there is no air, both of the objects, bowling ball and the feather, hit the ground at the same time. But if we consider only the drag force, the bowling ball reaches the ground much earlier. But if we consider the last case, the case when there is only the buoyancy force plus the gravity, and so you see that the feather, it takes a lot of time for the feather to reach the ground due to buoyancy force. So if you compare the case when there is buoyancy force and when there is drag force, the second column and the third column in the simulation window, you see that the buoyancy force is almost as much influential on the time it takes for the feather to reach the ground as the drag force. So as a conclusion, buoyancy force is another factor, important factor, that affects the time it takes for these objects to reach the ground in the gravity experiment that is shown in the BBC documentary hosted by Brian Cox. Okay, so this is all today. Don't forget to subscribe to my channel. Thank you. Bye bye.